All right, hey, hello, Algebra 2 students. This video is honestly meant to just be a quick review and also a tool that you could come back and watch at any time. Today, tomorrow, you can come back and watch it because I'm reviewing the four main skills that we learned with matrices, and then, of course, I'm going to want you to keep practicing it using that practice paper. All right, so addition and subtraction of matrices. This is honestly the easiest thing to do because really all you do is just add and subtract what we call the corresponding entries. Now, this particular problem does have one extra step. You'll notice that it has this 6 or -6, depending on how you want to think of it, that's in front of this matrix. This number is a scalar number, and it gets multiplied or distributed to the inside using a simple scalar multiplication. All that means is that each of these 8 numbers is going to be multiplied by 6. Now I'm going to choose to not multiply by -6 because I don't want to have a negative sign end up in 8 different places. I'm just going to leave that as a subtraction sign. So every number has been multiplied by 6. I still have the subtraction sign, and now I'm ready to subtract corresponding entries. The first corresponding entry would be 2 and 18 because that's the entry that's in the first position. And so it's simply 2 minus 18. Of course, you get -16. Next, we can subtract the corresponding entries 0 minus 6. Again, 0 minus 6, that of course is -6. Next, we're going to subtract -1 minus 0. -1 minus 0 is still -1. And lastly, we'll subtract 3 minus -6. Now be careful, 3 minus -6 is really the same as 3 plus 6, so that of course comes out to be 9. And when you go ahead and subtract the bottom 4 numbers, you end up with -45, 17, -20, and -12. We call that matrix addition and subtraction. Now things get a little more interesting when we do matrix multiplication. First, not every multiplication problem can actually be finished. You have to make sure that the dimensions match in the correct manner. Here we have a 2 by 2 followed by a 2 by 3. Remember, 2 rows, 3 columns. Now if the numbers in the inside, in other words, if the 2 matches with the 2, then that means that this problem can be done. And the reason it can be done is simply because we are able to take a row and match it with a column. And the process here, as I taught, is known as multiplying the row times the column and adding the results. So first we're going to multiply 5 times 4. And when you multiply 5 times 4, you get 20. But continuing, you're going to want to multiply 1 times -1. And of course, that comes out to be -1. Now you're going to want to add the result of these together. So when we add 20 and -1, that's going to give us our first answer that goes in our answer matrix 19. Next, we'll multiply the same row, but this time we'll multiply to the next column. And again, in this situation, we're going to end up matching the first number, namely 5 and 0. We're going to multiply those together. That, of course, is 0. And then we're going to match the second number, which is 1, and then this 3, which, of course, that comes out to be 3, and we're going to add that result. Now, that obviously is equal to 3, but make sure you write the number 3 in the first row, second column, since those are the numbers that we circled. Lastly, we're going to circle that row one more time, but move to the third column, and one more time we're going to match the numbers. So we'll match the 5 with this 1. We will multiply those together, and that gives you 5. We'll match this 1 with this 2, and when you multiply those together, that certainly gives you 2. You always want to add those results, and that final number, of course, is 7. It ends up in the first row, third column. When you repeat this process, you're going to circle the second row, but go back to the first column. You're going to match the first number with the first number. That gives you -8. And then you're going to match the next number with the next number. That gives you -3. -8 and -3 is -11. Next, you're going to want to stay in the second row, and you're going to want to move to the second column. When you circle the second column, you'll match the numbers and get 0 and 9. Those add up to be 9. And one more time, we're going to stay in the second row, but we're going to match up this last column Make sure you're doing it correctly because -2 matches with 1. That's going to give you -2. And 3 matches with this 2, which gives you 6. You add those together for a final answer of 4. So matrix multiplication is this method where you multiply a row times a column, and you add the result. Our next idea was known as a determinant. Now, a determinant is simply a single number that basically comes from following the determinant formula. Recall that the determinant formula says that if you have a 2 by 2 matrix, all you have to do is multiply the diagonals and subtract. So we have AD, we have BC, and then a subtraction sign. So with this particular matrix, when you multiply the diagonals, of course, you always start with the primary diagonal. You multiply 7 and 4, that's going to give you 28. You multiply 8 and -3, that's going to give you -24. But again, the rule says that you always subtract. And yes, in a case like this, we're going to be ultimately adding 28 and 24, and that's going to give us a value of 52. Now, keep in mind that 52 is known as the determinant of this matrix. And oh, by the way, the original problem said to evaluate, which is just kind of a generic word that means find the value. And because we had these vertical bars, you may notice they are just vertical bars, that tells us to find the determinant. So the determinant is always the diagonals being multiplied together and subtracted. Now, our last concept is the inverse of a matrix, and you might say that this is the one concept that has the most steps, but once again, we just need to carefully follow the formula for the inverse of a matrix. Now, that formula has 2 parts to it. The first part says that we have to find the determinant. That's the AD minus BC. But notice that once you find the determinant, that you write it in a fraction. In other words, you write it in the denominator of a fraction 1 over the determinant. Now, after you get the determinant and put it in a fraction, then you have to change some things around in the matrix. You're going to change the position of the numbers that are in the primary diagonal. You're going to change their position. And then you're going to change the sign of the numbers that are in the other diagonal. You're going to change their sign. And that, when put together, is known as the formula for the inverse of a matrix. And always remember that this fraction that's going to be in front of your matrix should be distributed to the inside. The reason it should get distributed inside is so we're able to simplify and end up with just one final answer. So let's see if we can apply the formula for the inverse of a matrix to this particular problem. It looks like that the first thing we need to do is find the determinant. It's nice to kind of label that as the determinant of A. And of course, that would be the diagonals once multiplied, then subtracted. And so we get a determinant of 2. Now what you want to do is you want to put that 2 in the denominator of a fraction known as 1 over 2. So you then can prepare to do the switcheroo. And the switcheroo is when you're going to change some things around in the matrix. It looks like that we're going to change the position of the numbers that are in the primary diagonal. So that means that a 2 will now be first, followed by the 3 at the end of that diagonal. And we just need to change the sign of the numbers that are in the secondary diagonal. If we change the sign of these numbers, we'll have a -4 and a -1. Now, the determinant this fraction that's in front, namely 1 over the determinant, that fraction needs to be distributed to the inside of this matrix, which really means that every number in this matrix is just going to be cut in half. And when you cut each number in half, you end up with a final answer, which we can call the inverse of A. And again, that final answer will just be every number that's cut in half. When 2 gets cut in half, it becomes 1. We'll get -4 cut in half. We'll get -1 cut in half, which will still look like a fraction. And when 3 is cut in half, it too will look like a fraction. So that final simplified matrix is your inverse. I hope this served as a helpful review. And again, a simple tool that you can come back and watch anytime that you need help with these 4 matrix concepts.